Hello everyone. I'm Dr. Pratik Maheshwari, and today I'm going to discuss about last mile delivery challenges, and we will see how simulation can help us to understand the different kind of remedies for different challenges come from last mile delivery. So these things we're going to see in this particular session. So I'm going to connect some academic research related things with this particular topic. So the major heading about this particular session is about last mile delivery and the related challenges. So if we talk about the delivery, specifically talk about the product delivery and connect with the academia and how simulation can help us to solve different kind of situations, different kind of problem formulation for different industrial problems. So I did one SLR that we called as structural review process. In the structural review process, I have used the last mile delivery related keywords in various database like Scopus, Web of Science, and also I have used Google Scholar to extract the information about the last mile delivery and what type of different softwares and different type of tools are used by different academicians or practitioners to solve these kind of problems. So when I gone through the literature, one of the prominent work I have seen from Remus in 2020, which talk about first mile delivery. And in the same paper itself, the paper was published in Transportation Research Part E. In same paper itself, they talk about the different stages where the different kind of challenges comes into the picture if you talk about supply chain. So they beautifully describe about how different type of stages comes in the supply chain, like first mile delivery uh, challenges, middle mile, and last mile delivery challenges. And they have incorporated various kind of situations like where the first mile delivery challenges comes into the picture, who will be the major stakeholders for that situation. For example, supplier, manufacturer. If you talk about that particular part of the supply chain, it means we are talking about first mile supply chain. Similarly, in between the raw material supplier to the end customers, we have a link. That link we called as middleman. So these particular linkages also very much important. And after COVID-19 situation, the use of the distribution centers and warehouses and also the distribution facilities is increases day by day. And if you talk about decentralization and centralization of supply chain, this particular middle stage is going to be used in various aspects. So in today's session, we will basically discuss about the last mile challenges. So I will going to discuss the case where the distribution and end customers can connect and we can generate what if what scenario and see how these type of challenges can be sorted out through the any logistics or any sort of tools. Whenever we talk about softwares, I always say or professors always talk about those are the black box. Whatever we will put some kind of output, we always find out. So we have to be very careful about what sort of information we are putting in the softwares, especially in simulation software, and how we are narrating the overall view. So in the same context, I'm going to represent here how we can simulate one of the critical aspect where the different distribution centers situated in India connected with the multiple number of customers situated in different part of the India. So the particular example or particular case study started with the raw material supplier, but we will more discuss about the distribution part where the distribution centers and customers are connected and how what if what scenario works in that particular situations. So how I came to this particular topic or what motivated me to come in this particular sort of discussions. So I've gone through various literature available in the last mile delivery can see on my screen. There are two prominent literature published in one is in EJOR and second one is Transportation Research Part E. So both were basically talk about the different type of challenges, especially when we talk about the drone delivery system at the last mile delivery, and also if we talk about the end-to-end challenges which customers are usually face during the whole supply chain process. So if you can refer these two papers, you may find out that how the last mile delivery is more complex nowadays, wherever the reverse logistic kind of situations comes into the picture. If the product is not suitable or not find useful for the customers, they usually go for the return of the product. So how this last mile delivery is more important nowadays. So for what we did here to understand what exactly the research gap and how this kind of software can help us to understand the different dynamics of last mile supply chain, I did literature review at the first stage. So we have used here the PRISMA approach for systematic literature review. If we talk about systematic literature review, we have in academia we have different type of review process to understand what exactly the research gave, what exactly the trend is there in the particular research domain and the practitioners aspect. So usually do various kind of review work. So Prisma is one of the kind of work where we understand what exactly is there in the present state of art and what useful things we can extract from the particular databases or the existing sources and uh, how this selected database or selected articles or selected report can be useful for the narrative generation for the future research or future research directions. So to understand this, first we conducted the SLR here to understand what exactly the problem faced by the different practitioners and academicians during the last mile challenges. So most of you are aware about the different kind of resource available through which we can extract the data. So I have used here Scopus and Web of Science. So these are the two prominent resources through which we can extract the number of good articles which is there in the present state of art. So it's important that how we can discuss about different type of keywords at the first glance. So selection of the keyword is also important. I referred one of the good article published by Professor Dimitri Ivano in IGPR. It's an article I think it's published in May 2025. So they talk about the type of selection process. Although the Prisma approach is not new, in 2014 itself it started by the researchers to understand the present state of art. I use the same kind of approach here and we fired the similar kind of keywords with a different combination. So the first glance we appeared with a 720 article published in between 2023 to 2025. So this is the dashboard of Scopus to which we have extracted the number of articles. Although we have done some of the criteria for the selection of the article, then those are the articles comes under the English language or the article should be published in peer review journals. So likewise, some criteria we have included. So this approach to call the screening to the screening process. Also, we have reduced the number of articles and we also excluded, as the Prisma recommended, some editorial notes and underrated documents. So through the eligibility, we will find out that total 112 articles are eligible for last mile delivery and the related challenges. Although the academicians can have divided this particular differentiation in other categories like perishable supply chain or non-perishable supply chain. I use both two kind of keywords here. So the focus of the main uh, aspect is like uh, how we conduct the different kind of simulation activities and targeting the research gap. So once we find out that total 52 articles are good for the last mile delivery challenges, we have gone through the abstract and also understand the full text reading process. And we came to know about the different types of challenges which prominently described by different researchers and practitioners nowadays. So like urban congestions, traffic situations, high high delivery cost, fair deliveries, then environmental impact, technological infrastructures, constraints, regulatory policy issues. So this type of major challenges I have found out during the literature review process. And one of the aspect I have picked here, like failed delivery aspect. So we will going to see how different distribution centers can be utilized, and if one distribution center is subjected to certain disruptions or certain kind of events where they are not able to produce effective services. In those situations, what would be the effect on overall supply chain process? So these things we can simulate, although in last different times, many research comes into the picture in terms of policy and regulatory issues, where people talking about the sustainability related issues and targeting the number of SDGs covered by the United Nations. So these are the prominent research gap I find out through the whole literature review process. So high cost delivery, urban traffic congestions, fair delivery situations, route optimization, inadequate infrastructure, reverse logistics and returns, lack of real-time visibility, environmental impact, delivery storage. So these are the topics generally people talk about in the recent literatures. So let's talk about the case study. I have targeted one of the aspect here, like end-to-end supply chain, and in between end-to-end supply chain, how distribution centers effectiveness can directly or indirectly trigger the whole supply chain in terms of customer satisfaction. So that aspect I have considered in this particular work. So the case study talk about the Indian manufacturing firm, which provides six different type of product. Each products is combination of different raw materials. So the raw material supplier is different, situated in the different part of India, and also the raw material supplier is providing the material toward the factory, and factory is connected with number of distribution centers, which distribution centers are connected with the multiple number of customers. So if you can understand the whole supply chain structure, it comes with the raw material supplier, then raw material providers to factory, factory to distribution center, and distribution centers to the customers. So we basically focus on the last mile delivery. Therefore, the distribution centers and the particular customers are will be the main player of this particular simulation. So various types of simulation techniques are there in the anyLogistix or most of the simulation tools. Most of the techniques talk about the discrete event simulation. Some of the techniques talk about the agent-based simulation, and another type of method like system dynamics, where we talk about the behavioral aspect about supply chain. So different type of people generally using different type of methodology in the context of supply chain and understand the simulation. Here we have used a discrete event simulation model. In discrete event simulation model, we generally have a preferred data set which talk about the customers, then path, then sources, then objective functions. Then also it also incorporate different type of allocation strategies. So these are the prominent structure through which we can input the data in the softwares, and how to analyze this, it will depend on the operator's wiseness and the type of objectives. So if my objective is to simulate the disruption for one distribution center, so we have to input the data in such way that the inclusion of distribution centers should be there in the objective. Then if you talk about the overall policy for the inventory management, so we have different type of policies in the logistic, like minimax policy, historical database review kind of policy, constant policies. So it depend on the type of commodity what we are dealing actually. Depending on that situation, we usually pick the maximum or minimization policy or constant policy or different the type of policy. It purely depend on the type of commodity to which we are dealing. So here we are dealing with the non-perishable items. So therefore, minimax policy we have incorporated in the particular model. So whenever we talk about the incorporation of the model, certain things generally people talk about. One is about set or where the number of items should be there in the model. Second thing is parameter. Third one is decision variable. Fourth, how we frame the objectives and number of constraints. So here, as I earlier told you, where in this particular case we have one factory which is connected with the multiple number of distribution centers. So the factory location and the distribution centers are connected through the road transportation, and these vehicle movements are described by the decision variables. And total objective function, or the objective function, is basically talk about how to optimize the overall supply chain cost by utilizing the different kind of what-if-what scenario. As I said, the different distribution centers or different type of decentralized approach is going to be used in this particular case. So therefore, you may find out that number of distribution centers are there, and how we check the availability of distribution centers. So that we will going to see here. So the set of distribution centers are denoted by DC, and total DCs are 10, and the set of customers location is denoted by J. This is more than 100 uh, customers, and set of vehicles. So one set of vehicles we use here for the transportation. Although there is a possibility in the logistic where through which we can insert multiple vehicles with multiple capability and capacities to transport the material from one end to the another end. Then, as I told you, we talk about whenever we talk about the what if what scenario, it means always we're talking about the specific period where we see the effect of different events. For example, if one distribution center is closed for a day, some days, then how whole distribution centers or how other distribution centers can behave and provide the output towards the customers, and how the excessive load of the particular distribution center can be managed by the factory. So this type of whenever we do this kind of arrangement, we always require a set of period. So in most of the cases, we usually simulate the data for 6 months or 1 year. Then here we have the number of parameters. So as I said, the supply chain is linear supply chain here. So distance from the distribution center I is connected with the customer J. Total number of customers here is 100, and the demand of the customer J. So here total 6 products are there, and each customers are asking about the different quantity of the 6 different products, and the capacity of the vehicle is K. The each vehicle we can consider all 6 type of products, and number of loading gates at the distribution centers is 10, because we have a total 10 distribution centers, and unloading the gate at availability at the customer J. Average loading time per truck is given in the data set. The average loading time per truck unloading, delivery customers, delivery cost for the distribution center to customer, that is also fixed, which we can put in the model. The larger number for the larger number of set, we usually prefer the binary constraints. And for decision making process, we have 3 decision making process here. One is delivery of the vehicle. Second, delivery from I to J, it means distribution center to the customers, and number of quantity. So what type of quantity we are sending from the distribution centers to the vehicles. So it depends on the type of any logistic model you are using. For example, there are professional models, educational models, and also the personal model available on the website of any logistics. So you can use there. Although there are certain constraints are there in terms of variables, but in most of the cases, simulation cases, the prediction models can be used in terms of uh, personal version. So here I have used professional version of anyLogistix, where we talk about the 6 different products, and the 6 different products names are product A, B, and C, D, and F, which is uh, generated by the factory and shared towards the customers, and then customers, then shared towards the distribution center, and distribution center is connected with the number of customers. So, if you talk about the data preparation, so either you can start with a scratch, or you can create a template and then you can input the data and do the simulation. So both two options are available. First, I have generated the number of products. So in the product column itself, you can see here. So see, there are total six different kind of products, and these six different kind of products is come from six different type of raw materials. So there are raw material suppliers, and these raw material suppliers are connected with the multiple number of raw material suppliers connected with the factories. Total 10 number of raw material suppliers connected here. We have import this particular model in anyLogistix and find out that what would be the total profit in the first scenario and how the service level behave towards the existing scenario. Then what we did, we changed the distribution centers strategies. First, among the 10 distribution centers, 4 distribution centers are working. Another 4 distribution centers are inoperated or we just exclude from the model, and then we run the simulation. So these types of simulations we did and generate the multiple aspect. Although in the whole analysis process, we find out that if we exclude the number of distribution centers, yes, the overall supply chain cost is reduced because the holding cost and carrying cost can be eliminated. But at the same time, the service level goes down. If we increase the multiple distribution center in the whole existing supply chain, then we can increase the service level. But at the same time, the overall supply chain cost is increases because it is subjected to the carrying cost and holding cost of the inventory. So it depends on how much resiliency we require in the whole supply chain process and how this resiliency can be helpful for the overall objective of the firm or overall objective of the supply chain. So it depends on what type of objectives, whether the objective of the firm is create a resiliency in the whole system, that we include that, so that we can include multiple distribution centers, and those distribution centers can be connected with the multiple number of customers. Recently, I'm working with another extension of this model where we're talking about the reverse logistics. So, in the reverse logistics from the customer's end to the factory, in the same model, we are working with the if product is not suitable for the customers or they don't like and they want to do the return of the product. So, how the similar kind of transportation strategy can be used for the shipment. So the constant programming, I'm using that constant programming in this particular model. So therefore, we can optimize the overall supply chain cost. So that is the future work which I am doing, which is aligned with the research gap. So that's it from my side.